Okay, here is the tutorial on using carrier block load for Parker services. So when you open the program, this is the first screen you're going to see, just the kind of license information. You're going to click OK. It's the updated updates to the program on the last upgrade they did. You might want to just click that "Do not show this message again" and do OK. And then it's going to bring you to um, the the file open screen. As you build your projects, they will populate within this window, but we're going to create a new one. So we'll click right here on New, and it brings up your basic. Um, this is the opening screen for a new project. So the first thing you're going to want to do is save the project. So you click on Project, and then Save As. And I've created this folder for my files, so we'll call this sample test project. This will allow you to kind of keep saving. I haven't had a problem with this one crashing, but in the past I've had them crash. So the first thing you're going to want to do is enter the weather. We're basically going to be working our way down this tree under the project tree on the left side. So most of your projects are going to be in Florida, and we'll pick Tallahassee. If you notice, then it auto-populates the summer and winter design temperatures. So let's go ahead. So you don't click OK. You just set your zone. So you have unattached zone and you have systems. So the unattached zone is a place where you can build zones to then attach to systems later, or you can go ahead and create a system and attach the zones directly to the system. So we'll call this system number 1 to keep track. And I'm just creating this. This is a single zone constant air volume. And I'm just going to leave the defaults in there for right now. I wanted to create this to show you, then you can right click and you can add a new zone. So zones are the spaces, the rooms that are being cooled within the system. So we're going to add a new zone. And for this particular one, we'll say it's a bedroom. So on this tab, you're going to work your way through the folder tabs. I'm going to go ahead and make this bigger so we can see them all. We're going to enter the information about the room. So general, that's where we named it. We might put how many square feet. So we'll say this is a 150 square foot bedroom, or you could enter it 15 by 10 and it'll update. You put your ceiling height and then your building weight. We'll discuss building weight in a separate video. Then internals, here's where you're going to put your lighting type. So you might have recessed unvented. That recessed meaning it's like a light that is up in the ceiling. You might have a free hanging light. Unvented and vented comes into play when you have a return air plenum. For the most part, we're going to be using unvented lights. I typically would do 0.5 watts per square foot. You may very well just put the number of lights. So you could change that to watts. And if we know we had 3 25-watt bulbs, then you would put 75 watts. Occupancy, so we'll put 1 person. Here you can change kind of the activity level you would expect them. Typically going to leave this as office work, except for a bedroom, right? Seated at rest is going to be more appropriate. If you'll notice, this as you change this option, it changes the heat. So for seated at rest, our person is creating 230 BTUs of sensible heat per person and 120 BTUs of latent heat. If I do office work, they're moving around, right? So we've noticed the sensible heat went up and the latent heat went up. You could also do electrical loads. Typically, for a bedroom, I would put 150 watts. That's going to cover a laptop or a computer. Here's where you're going to put your walls. You see we have options for 8 walls. So you first set the direction that the wall is facing. So we're going to say this wall is on the northwest corner. So we're going to have a north wall, and we are going to have a west wall. So we said that our building was 10 by 15. So we're going to say the 10 by 9, the 10 by 9 wall is on the west, and then the 15 by 9 wall is on the north. And here's where you will put windows in. If you'll notice, we have not created any windows. You can create a new window here, or before you start doing this whole process, you could come in here and create your libraries. But because I started creating this, I have to create a wall. So we'll do create a new wall. And it brings up the new wall assembly. So we'll just say our default exterior wall. We're going to say it's a brick wall. So this wall that we have here is face brick. There's a whole lot of pre-built walls, right? So maybe we'll say a brick house with R11 bat. That's a pretty standard house built in the 80s or 90s. Bricks are dark colored, and but it pre-fills in these items. Now you can say, if you know that they had R13 bat insulation in the wall, you can go ahead and change that. Notice it doesn't change this, but it does change the thermal properties of the wall. What I like to do is if I change it, then I go ahead and change the name so that it reflects what it actually is. Then we'll go ahead and create a Facebook R13 wall there. If you'll notice, since I created that from the bedroom space, it now puts it in my library. So we've got those two walls. We could then put windows. Notice here on the window type that we don't have a window. So I'm going to go ahead to the libraries and create a window there. So this will be a 3050, 5 by 3. You enter the U value. I will typically use 0.4 and 0.4. That's a pretty standard efficiency window. And now I go back to my bedroom, to my walls, and we're going to say I have one on the north wall, that is that 3050, and we'll put 2 on that larger wall of the 3050. We're going to create a roof. So I'm going to put a horizontal roof. Notice it automatically fills it with the area of the room. If it was a different sized roof for some reason, you could change that. And again, we got to create a roof type. So brings up our roof assembly. Since this one's a house, we're probably going to have asphalt shingles, maybe with the R38 insulation in the ceiling. And let's just say they had a lighter, like a medium color shingles. Now we've added a roof to that space. For residential, a lot of times we're not going to have outdoor airflow, so we're just going to leave those all at 0, and then we'll go to floors. So here, if we've got a concrete floor that's sitting right on the ground, we've picked the slab floor on grade. Is it carpeted? We'll say that this house has hardwood floors or tile. Carpet creates a little bit of a thermal barrier. That's why it's asking that. It pre-fills with the area that you entered on the general tab. The U value, we'll just leave that to its default. The perimeter is the exterior perimeter of the slab. So we have a 10-foot exterior wall and a 15-foot exterior wall. So 10 plus 15 is going to be 25 feet. And if they had insulation that extended down past the slab, typically in Florida, we don't have this, but you would put that R value of the insulation. Partitions is going to be used if, say, this bedroom had a wall that was adjacent to an unconditioned garage. Then you would use the partition. Partitions are different than walls because they don't take into effect the sunlight shining on the surface, but you do put the temperature that you would expect within that garage. So we're going to say this one has a 10 by 9, we'll say a 90 square foot wall. Let's say a 70. We'll say it's a 7 by 9. So a 70 square foot wall that is adjacent I typically will change that to 0.1, which is equivalent of like a R10 wall. And so the max temp of the unconditioned space, we'll say that it gets up to 80 degrees. What it's going to do is when the exterior temperature gets up to its max temp, then it will say that our garage temperature is 80 degrees. And then you want to do the minimum temp. So in the winter, let's say it cools off in that garage to 40 degrees. So we're done with our room. Now let's just go ahead. If we wanted to have 3 bedrooms, then I might just duplicate it. Let's say one of the bedrooms, so that was on the northwest corner. Let's say that this bedroom is on the northeast corner. We'll say this is bedroom 2. If you notice, I completely duplicate it. So everything is going to be the same, but we know that this one is the same size, but it's on the northeast. So I would just change that wall to the east. I could create this from scratch, but sometimes it's easy just to duplicate it. In fact, what I'm going to do, see, our roof stays the same, our outdoor airflow, our floors, all of that's good. What I'm going to do is I'm just going to make 4 of these. So that was we've got a northwest, a northeast, bedroom 3, we're going to say is a southeast. So I'm just going to change that north wall to a south. And we're going to create a southwest. So now we have 4 bedrooms attached to this one system. Each bedroom has a 15-foot wall, a 10-foot wall. It's got windows. We might add some doors. Let's say on this particular bedroom, on my windows, walls, and doors, if you notice down here, we had an option to add doors. So we're going to say it's a 3x7 or 21 square foot. Create a new door type, 21, or I could do a 3x7. This is the defaults are generally pretty good. I did 21. We want one of these default doors. So now we've got 4 rooms attached to a system. So what do we do now? We want to calculate what size that system is. What I'm going to do here is look at, so the settings in the system are going to say our system starts up at 6 a.m. and it runs for 24 hours. Basically, it runs 24 hours a day. We could say it starts up at 6 a.m. and it only runs for 8 hours. That would be typical maybe of a business if you knew what their business hours are. But we're going to leave this running for 24 hours. Central heating is used. We want our heating supply air temperature. We'll just leave the defaults there. We might say 90 degrees. A heat pump is probably going to give you closer to an 85 or a 90 degree temperature. Or you can just leave the defaults in. Our climate is cooling driven, but sometimes you need to put some thought into your heat pump heating really for your auxiliary heat. That would be a separate video. Our supply fan, most of our systems are going to be a draw through. What that means is the fan and the heat generated by that fan is after the cooling coil. So we would expect the air to heat up a little bit after the cooling coil. A blow through means that the cooling coil would be handling all of that heat from the fan motor. And I typically am going to put 0.5 inches of static pressure. That is used to determine the amount of heat that the fan will create. Plenum safety factor, you might put a safety factor. Typically like to stay away from safety factors because you're going to upsize the unit after you run your load calcs. But this system is ready to go. We can size it. So with the Carrier software, right here is this view design reports, the little blue triangle. I think it's like a protractor. You want to click that. And it gives you all these different reports. Really, the ones you need are the system load summary or the system sizing summary, You typically don't need the system psychrometric graph. I like the zone load summary. This will tell you the airflow in each room. And there are some advanced reports, but we're just going to look at these basic ones. System sizing, system load summary, zone load summary. And you click preview. It generates the system sizing report. So we had those 4 150 square foot spaces. So we've got a 600 square foot floor area for the system. This one is saying we have a total coil load of 1.1 tons or 13.2 thousand BTUs per hour with a sensible load of 12,400 BTUs. It's saying we have 714 CFM of supply air needed. What this is telling me is we're probably more like a 1.5 ton for this particular building. That is larger than the 1.5 tons is 18,000 BTUs. We're saying we really only need 13,200, but we have 12,200 of sensible load. That's going to be closer to the 1.5 ton to get you that sensible load. We normally are going to size based on the sensible load first. From here, you can create a PDF, you can print, you can go to the next page. So you might just scroll down. So this is that air system sizing summary. Here's your design loads. This gives you a summary. I use this to troubleshoot. If the size of the equipment seems way off to me, I might come in here and look and see where we have a lot of, maybe it's too high, where we have a high sensible BTU load. This right here, some of these might jump out if you're troubleshooting. And then your zone loads. This one is good because it tells you how much airflow. I'm sorry. This one's different than the system I used to use. I wanted the room by room. Let's go ahead and close this. And I'm going to redo my system. Zone load summary. Preview. Oh, here's the one. It's on that system sizing summary. It tells you how much airflow for each bedroom, right? So we had bedroom 193. That second room, that was that northeast, would get 160. Bedroom 3 was that southeast, 165. That makes sense, right? The south wall gets more heat load than the north. And then that southwest, 197. Southwest is generally going to be your highest heat gain, highest cooling load for a system. Now, I want to show you, so we had 714 CFM. I'm going to close this report. We're going to go to our system, and I'm going to change my cooling supply temperature. We're going to change it to 55 degrees. Properly operating system may very well should cool down to 55 degrees, maybe 56 degrees. We'll leave it at 55. So we had it at 58. We changed it to 55. I want to show you what that does to our system sizing. Notice the required airflow went down to 607 CFM. Because that air is cooler, it needs less air to cool the space. But our total cooling load did not change. Still shows the 1.1, the 12.3 thousand. It's just less airflow, which this is going to coincide more with a 1.5 ton system. So that's a basic run through. Then you want to save your project, and you've created a project.